If I'm looking at an example of cosecant, you're going to start the same, but first we got to identify what's the reciprocal of cosecant, and that's going to be sine. So sine is that reciprocal. We're going to start how we've always been doing. Start with the amplitude. Well, with the amplitude, now we got a negative number, which means it's still going to be 2. When I'm asking for the amplitude is going to be 2. From there, we're going to find the period. And the period, this pi x, we can imagine that there's parentheses right there. So we can have it as 2 pi over x, or 2 pi over pi, which is 2. It's okay if pi is not involved in our period. Now we're going to divide 2 into 4 parts, so that'll be 2 over 4, which is going to be 1/2. And then from there, we're going to look at our phase shift. Now the phase shift is setting that pi over x equal to 0. Well, when we divide both sides by pi, we'd find that x is equal to 0. So then the last thing is our vertical shift, and the vertical shift is -4. So meaning that if I'm looking at vertical shift of -4, my amplitude is 2, so that would be going up to -2 and down to -6. So if I make my line of scrimmage right here, I'm going to have it where -4, then up 2 to -2, and -6, just kind of representing those 3 marks. Now, to represent my 5 x values here, cosecant still is going to be like sine. Start with the phase shift in the beginning. The phase shift was 0. Quarter period was 1/2. That means we're increasing by 1/2. So my quarter period, I'm adding 1/2 each time. So it'll be 1/2, 2/2, 3/2, and 4/2. You're welcome. You don't have to do it this way, the way that I'm doing. You're welcome to just simplify it in the beginning. I just like to do this so that I know that I am constantly increasing by the same rate. So when I label my x-axis, I'm going to have it where this label here is going to be 0. And then I'm going to increase to 1/2. And then 1, 3/2, and 2. So here's the thing. Sine, when we graph it, starts at the origin of our intersection there. Now, because it's negative, rather than going up, we're going to flip it, and we're going to go down. So I'm still riding a roller coaster. I'm just kind of riding it upside down now, or backwards. And again, we're not going to connect the dots. Wherever you notice that there's an asymptote, or wherever there's an x-intercept, we're going to draw an asymptote there. So we're asymptote at each x-intercept. And then wherever there's a peak or a trough, we're going to draw a parabola connecting at that particular dot. Keep in mind that the parabolas do not go through the asymptotes. And that's sine, cosine, secant, and cosecant. Now we get to tangent and cotangent. Tangent and cotangent is the exact same thing. The only difference between tangent and cotangent is going to be the period, but we'll get there. So for the amplitude, we got another -1, so we're going to have it where the amplitude is 2. Now, I just want to let you know, tangent normally looks something like this. That's not a great picture, but it looks something normally like that. When you flip it with the negative, it looks like cotangent, where it's kind of flipped the opposite way there. So tangent kind of looks like an x-cubed graph almost, but that's just besides the point. I just want to let you know that's what it looks like. Now, period here. Period, the way that we find that is going to be doing 2 pi over b. Now, this b is this 1/2. How do we do 1/2, 2 pi over 1/2? Well, we take that 2 pi and multiply it by the reciprocal. So our period now will be 4 pi, with the quarter period being the 4 pi over 4, which will be pi. Now here's, error. Forget what I just said right here. Forget what I just said. This is wrong. This is wrong. This is wrong. Let me tell you why it's wrong, guys. For tangent and cotangent, the period is not 2 pi. Sorry, I'm a little tired. The period is not 2 pi. The period is pi over b. So let me restate that. For tangent, the period is pi over b. Tangent and cotangent, pi over b. So rather than it being 2 pi over 1/2, it's just going to be a regular pi over 1/2. So then we'll multiply that by a circle. So then the period's 2 pi, with the quarter period being 2 pi over 4, which is pi over 2. From there, we'll look for our phase shift. Well, the great thing about this phase shift is there is none, because it's just 1/2 x is equal 0, and we'll find the x is 0. And the great thing is, finally, there's no vertical shift. So far, so good. Now, what I'm going to do, because the period is only pi, I'm just going to leave right here. That's going to be my starting point for my x values. For the phase shift for tangent, this is the change, guys. Rather than starting in the beginning, the phase shift starts in the middle, meaning that my phase shift is at 0, and I'm going up a quarter period, so that means I'm adding pi over 2 each time. So this will be pi over 2 and 2 pi over 2. And then if I'm going up, I'm adding. What do you think I'm doing down? Subtracting. So that'll be negative pi over 2 and then negative 2 pi over 2. Now let's do some simplifying. If we're going to simplify, we're going to scratch this out and get a negative pi, and then we're going to simplify that to get pi. So what that means, at both ends here, we're going to have what is known as an asymptote, which is what we graphed on the other graphs. So if I'm going to label, I'm going to again do the 2 spaces away. So if this was 0, I'd increase the pi over 2, and then increase the pi, and then decrease the negative pi over 2, and decrease to negative pi. That means at the ends, I'm going to have an asymptote at both ends. So I'm going to have an asymptote here and an asymptote here. For tangent, to graph it, we'll start in the middle at that intersect on the x-axis. Now normally, tangent will rise to the right and fall to the left. But notice there's a negative. So rather than rising to the right, what we're going to do with the negative, we're flipping it. So now rather than rising, we're falling to the right and rising to the left. And where are those values, you might ask? Well, it's going to be on our 3 key y values. Notice that our vertical shift was 0. Well, the amplitude would be up 2 and then down 2. So this is going to be essentially labeled 0, up 2, and down 2. Now, my shoulder points are going to be at the quarter point and the amplitude intersection. So the quarter point and the amplitude intersection, just like that. So rather than focusing on 5 dots, we're just focusing on 3. And then I'm just going to connect it where I have an upward arc to the left and a downward arc to the right. So hey guys, we're almost done with this video. We just got one more to graph, and that's cotangent. And save the best for last. Now, as far as what a cotangent graph looks like, normally looks something like this, where we have something like, that's what it looks like. It looks very similar to what we just drew here as tangent, or negative tangent. So we're going to start with the period, or not period, the amplitude, just like how we've always been doing. So amplitude, this case is going to be 3. Hey, here's the thing, guys. If there's no 3 here, just want to let you know, if there was no 3 there, the amplitude would be 1. I'm not sure if you know that or not, but if there's nothing in front of the sine or cosine, whatever trig function, the amplitude would be 1. Kind of like how it is with this x here for our period. Now, our period is not 2 pi over b. What is it? Pi over b, that's right. So it's pi over b, so it's pi over 1, so our period's going to be pi. Our quarter period then is going to be pi over 4. And then for phase shift, my phase shift is going to be setting that x plus pi over 2 equals 0. So x is going to equal negative pi over 2. And then the last thing is vertical shift is going to be equal to negative 6. So I'm going to do my vertical shift first, because I forgot to do it almost last time. So that'll be negative 6. Our amplitude's plus 3. So I'm going to do negative 6 plus 3 to get negative 3, and negative 6 minus 3 to get negative 9. So that means here it's going to be negative 6. I'm going up 3 to negative 3 and down 3 to negative 9. This is just kind of like where I'm labeling my graph. Now, what we're going to do is find those x values. Now, again, 5 key x values, but here's the key difference. Cotangent is going to be like everything else. So the phase shift is going to be at negative pi over 2. And what are we increasing by? Pi over 4, that quarter period. So we're going to do negative pi over 2 plus pi over 4. The way we find it, we've done this before. We multiply it by those values, so we'll get negative 2 pi over 4 plus pi over 4. So that'll be negative pi over 4, then 0, then pi over 4, and pi over 2. From there, I'm going to just kind of have it where I move my line of scrimmage. The reason I'm moving my line of scrimmage over is just so that I have enough room. With cotangent, we're going to have it where we start on the line of scrimmage as our first point. So that's going to be that negative pi over 2. Then I'm going to increase to negative pi over 4, 0, pi over 4, and pi over 2. The reason I'm doing this is because again, we're going to graph this like tangent. At the end points, at the beginning and end point here, I'm going to have what are known as asymptotes. And those are known as my asymptotes. Then I'm going to find that center point, which is going to be the point right in the middle of the asymptotes, and that'll be my x-intercept. And then cotangent will rise to the left and fall to the right based on those quarter periods. And that, friends, is cotangent. That is all I have for y'all today. And hopefully good luck on the test on Thursday or Wednesday.